Let's try to find the refractive index of the prism. Here ABC is a triangular prism. PQ is the light ray which strikes the surface of the prism AB. After striking this prism at Q, it undergoes refraction along QR. Here PQ is the incident ray, QR is the refracted ray. You can find one more ray here, RS, which undergoes one more refraction after crossing the boundary of the prism. Therefore, the light ray PQRS is the path of the total light ray. Here PQ is the incident ray, QR is the refracted ray in the prism, RS is said to be the emergent ray. So in this triangular prism, here we are drawing a normal Qn1 to the surface of the prism AB. One more normal is there, Rn2. It is also a normal to the surface of the prism AC. These two normals are extended so that they meet at a point N. Here I is the angle of incidence, E is the angle of emergence. Now let us try to apply the principles of geometry to derive the formula for refractive index of the prism. Here AQNR is a quadrilateral. Therefore, from the quadrilateral, AQNR, angle A plus angle QNR is equal to 180 degrees because opposite angles are supplemented here. From triangles here, QNR, from triangle QNR, angle R1 plus angle R2 plus angle QNR is equal to 180 degrees. Let it be the equation 1. Let it be the equation 2. From 1 and 2, right hand sides are equal. Therefore, left hand sides angle A plus angle QNR is equal to angle R1 plus angle R2 plus angle QNR. I am removing this angle QNR both sides. You will get angle A is equal to angle R1 plus angle R2. This is one relation you have got here. Now you see here I is the angle of incidence. These two are intersecting lines. Therefore, these two angles happen to be vertically opposite angles. When you consider this part of this angle, this one is totally equal to I. When you consider this part only, this becomes I minus R1. This part becomes E minus R2. Therefore, here this is a triangle. When you produce this side up to this end, an exterior angle is formed. In a triangle here, exterior angle is equal to sum of the interior opposite angles. Therefore, delta is equal to I minus R1 plus E minus R2. Therefore, delta is equal to I plus E minus of R1 plus R2. When you make an adjustment in such a way that the angle of deviation delta is minimum, in such a case delta becomes dm. Delta becomes dm. This is called the angle of minimum deviation. When you adjust the prism in such a way that it undergoes the angle of minimum deviation, R1 and R2 become equal. Similarly, I and E also become equal. But R1 plus R2 is equal to A here. Therefore, I plus E minus A, because A is equal to R1 plus R2. We can write this one as I plus E is equal to A plus dm. A plus dm. Since you have adjusted the prism in such a way that the angle of minimum deviation is there, I and E become equal. Therefore, E can be replaced by I. Therefore, I plus I is equal to A plus dm. A plus dm. Therefore, 2I is equal to A plus dm. This implies I is equal to A plus dm by 2. I is equal to A plus dm by 2. But you have already adjusted the prism in such a way that the angle of minimum deviation is there. In such a case, R1 and R2 are also equal. Let R1 is equal to R2 is equal to R. Therefore, R1 plus R2 is equal to 2R is equal to A. This implies R is equal to A by 2. But according to Snell's law, mu is equal to sin I by sin R. Therefore, mu is equal to sin I is equal to, we already know that A plus dm by 2 by sin R, sin A by 2. This is called the refractive index of the prism. Mu is equal to sin A plus dm by 2 by sin A by 2. So this is used to find the refractive index of a triangular prism.